In the last video, we determined Kc to be 4.6 times 10 to the minus 2. But does that mean that's a large number? Is that a small number? And how can we look at these values and kind of get some information about the reaction? So when we talk about the magnitude of equilibrium constants, remember that K is going to be equal to the concentration of products divided by the concentration of the reactants. So if K is large, that means the concentration of the products is going to be much greater than the concentration of the reactants. If K is small, then the concentration of the reactants is going to be much greater than the concentration of the products. Okay, so this has an impact on how the equilibrium is going to shift, or if it's going to lie in the forward direction or the reverse direction. So if we have a very large K, that means the reaction is mostly complete. And by mostly complete, we mean we have mostly products. Because at equilibrium, the concentration of the products is much greater than the concentration of the reactants. So an example of this is if we have 2 NO gas plus O2 gas in equilibrium with 2 NO2 gas. In this case, Kp is equal to 1.6 times 10 to the 12th at 25 degrees Celsius. So this means we have mostly products. So we are going to have a large amount of NO2 and very small amounts of NO and O2. So we can say that this reaction favors products. If we have a very small K, that means the reaction does not proceed forward readily. And again, we're going to have mostly reactants, because the concentration of the reactants is much greater than the products at equilibrium, and the forward reaction does not occur to a significant extent. For example, if we have solid carbon reacted that with water in the gaseous state in equilibrium with carbon monoxide gas plus hydrogen gas, the Kp for this particular expression is 1.6 times 10 to the minus 2 at 25 degrees Celsius. Okay, so in this particular case, we're going to favor the reactants over the products because we have a K that's 1.6 times 10 to the minus 2. As kind of a baseline, you can look and say where K equals 1. So if this is kind of like a number line right here, and we have K equal to 1, and if we have a K smaller than 1, we're going to be reactant favored. And if K is larger than 1, we're going to be product favored. And if we're around close to 1, that means there's going to be an appreciable amount of both products and reactants. So there's kind of going to be, like a little range here where we can have both products and reactants. But over here, with values that, are less than 0, or, values that are greater than 10, we can definitely for certain say that we have either products favored or reactants favored. So the magnitude of K is going to give us a lot of information about a particular equilibrium expression. So make sure you understand how this is derived.